To run an AI coding agent like AMP, you need to give it access to your files and the ability to execute code, but you don't want it running directly on your host machine. Today, we are going to configure a custom Docker kit that keeps the AMP agent locked safely inside an isolated sandbox. By the end of this process, you will have three things: a completed spec.yaml configuration file, an AMP API key safely stored on your local machine, and a live interactive sandbox. You need 4 tools ready before we begin. First, Docker Desktop, the SPX command line interface, an active AMP API key, and your preferred code editor. This step-by-step setup ensures the agent's environment is tightly contained, while still giving it the exact tools it needs to write and execute real code. First, create a new project folder named AMP and initialize a blank file called spec.yaml. We start by defining our base image. Coding agents require a generic environment, but they frequently need to run their own temporary containers to test the code they write. The shell Docker template provides exactly that capability. Below the image definition, add the agent and memory block structures. These sections define how the AMP agent launches and what initial context it receives. Inside the agent block, set persistence to persistent. Without this setting, AMP drops its authentication tokens and chat history every single time the sandbox restarts. The memory block primes the agent at launch. Any markdown you write here is automatically appended to an agents.md file, giving AMP its base instructions the moment it boots up. These foundational blocks give the AI a persistent identity and a clear set of rules, while the surrounding sandbox remains entirely ephemeral. Next, we add a commands.install block to run the script that downloads the AMP binary. By default, install commands run as root. This places the binary in the /root directory, where the agent cannot reach it. You must explicitly set the user to 1000. This ensures the binary lands exactly where it belongs, in the agent's home directory. Next, the network block configures an outbound proxy mapping ampcode.com to a service identifier. When AMP requests that domain, service-auth automatically injects a hidden authorization header. List only the specific host. Wildcards force TLS intercepting mode for all subdomains, corrupting the agent's binary CDN downloads. Precise, narrow network mapping allows you to secure your outbound traffic credentials while keeping the integrity of your external package downloads completely intact. With the YAML configuration finished, open your terminal to securely register your actual API key. Run SBX secret set custom, passing the specific API host domain. This securely stores your real key on your local machine, instead of inside the sandbox. The terminal prompts for a placeholder. Because AMP locally validates the key's format at boot, append a .rand_thfix. This generates a syntactically valid string to satisfy AMP's check, which the proxy then swaps for your real token on the way out. This isolated swap at the proxy wall ensures the real API token never enters the sandbox. Even if the container is compromised, the host's actual token cannot be exfiltrated. Execute the SBX run command and pass the kit flag to launch the completed specification. Open a second terminal tab and run SBX policy log to monitor the live network traffic. As the agent operates, it might try to reach model providers or update servers. The policy log will show these as blocked requests. Read the log, identify the necessary addresses, and iteratively add them to your allowed domains list to fix any errors. Actively monitoring the policy log is the absolute safest, most transparent way to map out undocumented network dependencies. You give the agent exactly what it needs without exposing the sandbox to the open internet. The AMP agent is now successfully initialized. It is persistently storing its state and is ready to accept prompts inside its isolated environment. This decision framework, selecting a base image, mapping the proxy, and using secret placeholders, can be directly adapted to build kits for other agents, like Claude Code, Codex, or custom builds. Once your kit is working, you can package it as a zip file or push it directly to an OCI registry to distribute it to your team. By containerizing AI agents with custom kits, you completely protect your host systems while allowing the agent to execute code, run containers, and solve problems.